Welcome. This video will explain Kirchhoff's voltage law and go through a simple example that shows how it can be applied. So the idea behind Kirchhoff's voltage law is that the sum of voltages that you encounter as you go through any closed path in a circuit is equal to 0. So to give you a more concrete idea of what that is, I've drawn some circuit here. It has a 10-volt source. It has a component, or it has components with 4 volts across them, 3 volts across them, 1 volt, 9 volts, and 5 volts across them. And I'll draw a closed path through the circuit. We'll start with an ugly color. So suppose I go this way, and then coming to this junction, I go down, and I go around like this, and back up through the source to where I started. So that gives me a closed path through the circuit. And as I go along this closed path, again, we'll assume we're starting right here. As I go along this closed path, I keep track of the voltages that I encounter. And if I encounter a voltage going from a higher potential to a lower potential, as I would here, so this is higher potential to lower potential, I write it down as a positive voltage. So the first voltage I encounter is 4 volts. Okay, now I turn the corner, I encounter the 1 volt drop, and again I'm going from higher to lower potential, so I can say that's 1 volt. Then I encounter the 5 volt drop, so I'll write that down. And now I come all the way around the circuit, back up to the 10 volt source, and now I'm going from a lower potential to a higher potential. So I write this as a negative 10 volts. And Kirchhoff's voltage law says that the sum of the voltages like this that I've encountered will be 0 volts. And you can see that in this case 4 plus 1 plus 5, that gives me 10, minus 10 does indeed equal 0 volts. Well, let's try a different path through the circuit. Okay, again starting up here, I'll go through this load, and now I'll go around the other branch. And then keep coming along, back up through the source. Okay, and so on this path I again encounter the 4 volt load from plus to minus. The next load that I encounter is 3 volts, but now I'm going minus to plus. So that's going to be minus 3 volts. I encounter 9 volts, and then I go all the way around and get the source 10 volts, and this does again equal 0 volts. So this is pretty cool. Let's do something a little differently. Let's start again up here, but now I'm going to go through the first element. But instead of actually going through the rest of the elements in the circuit, I'm going to go off-road. So I'm actually going to just go straight down to this node and then back up to my source. Okay. Now, in order to apply, I can actually still use this path. Actually, I need to go all the way up to where I started. I can still use this path because I have a path that goes through the circuit. The thing that I don't know, and which I might want to find out, is this voltage from this node up here to this node down here. Well, let's apply Kirchhoff's voltage law and see what happens. So again, I start up in this corner. I go over the 4 volt element from positive to minus. I now go over the unknown voltage V from positive to negative. I hit the source going from negative to positive, and I know, since I've gone through a closed loop, that's going to be equal to 0 volts. Which means then that this V, the voltage that's unknown, I can solve for. And when I solve for it, I find that V is 6 volts. So I can actually use Kirchhoff's voltage law to solve for unknown voltages. What that tells me, again, is that the voltage from this node to this node is 6 volts. And sometimes when you're solving circuits, being able to find the voltages between two nodes in a circuit can be very helpful. So let's do one quick example that will hopefully make this clearer. Basically what I have here is a voltage source, and this voltage source is connected to 5 light bulbs which are in series. Okay, and each light bulb will represent by a resistor. We model light bulbs, incandescent bulbs, by resistors. So each of these guys models a light bulb, and I know that the light bulbs are designed to work with 2.4 volts across them. So the question is, if I have 5 light bulbs connected like this, how large do I need to make V sub s in order to give the light bulbs the proper voltage? Well, again, I can apply Kirchhoff's voltage law. So I'll start up in this corner, go this direction, around the loop, and in this circuit it's actually pretty easy to tell what the loop should be because there's only one loop in the circuit. So as I went that direction, I encountered the first light bulb, which had a voltage of 2.4, and I'm going from high potential to low potential, so this is a positive 2.4, plus another 2.4, plus a third 2.4, plus a fourth 2.4, plus a fifth 2.4, and this, then I have a minus V sub s. That's negative because I'm going from a negative to I'm going from a lower potential to a higher potential in the source, and this is all equal to 0. So I can solve for V sub s, and I get V sub s is 2.4 plus 2.4 plus 2.4 plus 2.4, and when I add these guys together, I get 12 volts. So what this tells me is that if I want to give these light bulbs the proper voltage, I would need to have a source voltage of 12 volts, which is not that realistic of an example, but it does illustrate Kirchhoff's voltage law beautifully. So that concludes this video.